Welcome to video lecture number 4, Chemical Equations. In this video, you'll apply your knowledge of chemical formulas to learn how chemical reactions can be represented through written chemical equations. We'll also learn about the law of conservation of mass and how to determine if a chemical equation is balanced or unbalanced. Go ahead and pause the video and write the essential question in your notes. Imagine that you had enough supplies and the recipe to make one pepperoni pizza. I hope this analogy doesn't make you hungry. The recipe might include a ball of dough, a cup of pizza sauce, a cup or two of cheese, and 20 or 30 pieces of pepperoni. Although you could cut it into several pieces after you made the pizza, it would be impossible to turn one pizza into two pizzas of the same size without having more dough, sauce, cheese, and other ingredients. It would also be impossible to put a pepperoni pizza into the oven and have it turn into a mushroom pizza while it's baking. Thank goodness, right? Just like a recipe, chemical reactions depend on the starting substances. They're made of certain atoms, and after the reaction you will have the same atoms. In a chemical reaction, molecules undergo a change. Atoms rearrange to form new substances. Chemical equations are written to show what happens to the atoms in a chemical reaction. A chemical equation shows the changes in the arrangement of atoms, but the atoms you begin with, you have to also end with. If you recall, the starting substance in a chemical reaction is called the reactants. In a chemical equation, the reactants are usually written on the left-hand side of the equation. The products of the reaction are the substances that result from the reaction. Products are usually written on the right-hand side of the equation. The reactants are separated from the products by this arrow. The direction of the arrow points to the products in the reaction. You read the arrow by saying yield. The reactants yield the products. For example, you would read this chemical equation: hydrogen and oxygen gas react to yield water. The easiest way to remember what goes where in a chemical equation is with the acronym RAP, which stands for reactants, arrow, products. In the reaction above, one molecule of O2 reacts with two molecules of H2 to form two molecules of water. You know this from the coefficients, the big numbers, in front of each substance. A coefficient is used in a chemical equation to show how many molecules take part in the reaction. H2 and H2O each have a coefficient of 2. This means 2 molecules of hydrogen gas are needed when you're forming 2 molecules of water. Only 1 molecule of oxygen gas is needed to form 2 molecules of water. The equation from the last slide is called a balanced equation because it follows the law of conservation of mass. The law of conservation of mass states that matter cannot be created or destroyed during a chemical reaction, and it has to be followed when you write a chemical equation to represent a reaction. In the same way that you can't create that mushroom pizza from a pepperoni pizza, the same atoms must be included, the same ingredients have to be included in both the reactants and the products of a chemical equation. A chemical reaction doesn't create new atoms. It doesn't destroy atoms to make that new substance. It just rearranges atoms that are already there. Here's the same chemical reaction that we've seen before, but written in an unbalanced fashion. What the law of conservation of mass means is that all of the atoms in the reactants have to be used to form the products. In this equation, one of the oxygen atoms doesn't get used to make water, the product. So we say that it does not follow the law of conservation of mass, or that the equation is unbalanced. Look at the equation in the top diagram on the right. It says unbalanced. This equation shows the reaction of methane with oxygen gas. The product is carbon dioxide and water. This equation is not balanced. There's one carbon atom on each side of the equation, so the carbon atom is balanced. But there are 4 atoms of hydrogen on this side of the reactants, and only 2 atoms of hydrogens on the side of the products. There are also 2 atoms of oxygen on the reactant side, and 3 atoms of oxygen on the product side. In order to balance an equation, coefficients can be added or removed from the formula in the reaction. In the previous equation, the hydrogen atoms can be balanced by adding a coefficient of 2 to H2O. Just notice, when we add a coefficient, we don't change the substance. It's just 2 molecules of H2O. So you can never make an equation follow the law of conservation of mass by changing subscripts. If we did that, then we would be changing the substances that are represented in the reaction. The oxygen atom can be balanced by adding a coefficient of 2 to the O2. At this point, there are equal numbers of carbon, hydrogen, and oxygen atoms on both the reactants and product side of the equation. There are 4 atoms of hydrogen, 1 atom of carbon, and 4 atoms of oxygen on both sides. To balance a reaction, you have to confirm that all of the atoms in the reactants are exactly the same as all of the atoms in the products. In this way, the equation is written so that it follows the law of conservation of mass. So now we know that in order to tell if an equation follows the law of conservation of mass, we're back to counting atoms. I create a T-chart for the reactants and another T-chart for the products unless the type and the number of atoms in the reactants is identical to the type and number of atoms in the products, then the equation is not balanced. Let's try an example. In this chemical equation, there are 2 elements in the reactants, hydrogen and nitrogen, and there are 2 in the products, hydrogen and nitrogen. So that checks out, at least the elements are the same. The type of atoms are good, but let's look at the number of atoms. 2 hydrogen atoms and 2 nitrogen in the reactants, but only 1 nitrogen atom and 3 hydrogen atoms in the products. This is an unbalanced equation. We can't destroy a nitrogen atom and create a hydrogen atom in a chemical reaction. That's like putting in pepperoni pizza and taking out mushroom pizza. Impossible. Now let's look at the same equation with new coefficients. Remember, coefficients don't change the identity of a substance. They just represent the number of molecules that there are. So we still have the same elements in the reactants and the products, hydrogen and nitrogen. But now we have 6 hydrogen atoms and 2 nitrogen atoms in the reactants. And we also have 6 hydrogen and 2 nitrogen in the products. The equation is now balanced. Thanks for watching.